Hello, today I make dimethyl oxalate from oxalic acid and methanol in high yield. Dimethyl oxalate finds various applications in organic chemistry, but I use it to create candles with colored flames. However, I plan to experiment with trimethyl citrate in the future, because dimethyl oxalate has some drawbacks, such as sublimating at room temperature, which is bad for candles. This is a simple esterification reaction where oxalic acid and methanol forms dimethyl oxalate, liberating water as a byproduct. The reaction actually reaches equilibrium, but we can shift it to the right by removing water. To do this, I add sulfuric acid, which also accelerates the reaction. Previously, I used oxalic acid dihydrate, which already contains 2 molecules of water. That significantly reduces the yield to about 50%. See the scheme: if we add water to the right side, we are shifting equilibrium to the left. Using anhydrous oxalic acid allows us to increase the yield to around 90%, so I choose to dry my oxalic acid beforehand. There are 2 methods to achieve this. The ideal method, as described in Red's video, is azeotropic drying using Dean Stark apparatus. But since I don't have one, I use a simpler method. I heated the oxalic acid to 95-110 degrees until it lost 15 to 17% of its weight. I did this in an oven dedicated to chemistry. This took about 2 hours. It's crucial to not heat it longer than necessary, as oxalic acid can partially sublimate under these conditions. Now my oxalic acid is dry, the esterification reaction is straightforward. I followed the synthetic procedure outlined in orgsin.org. A link will be in the description. I mixed methanol and oxalic acid, then slowly added concentrated sulfuric acid. The mixture heated up almost to boiling upon addition of sulfuric acid. If not, gently heat it on a hot plate until it began to boil. Afterward, I cooled the mixture in the fridge for a day. A large amount of crystals precipitated from the cooled solution, making it challenging to crush them. I used a suction filtration to separate the crystals from the liquid, and washed them with ice-cold methanol. Then I dried them for half an hour. Since the methyl oxalate sublimates at room temperature, I recommend drying it in desiccator bag for 1-2 days with calcium chloride to remove all the water. This is my version of desiccator bag. Here is my wet dimethyl oxalate, and here is calcium chloride. Avoid using sodium or potassium hydroxides as desiccants because they react with dimethyl oxalate. In the end, I obtained almost 200 grams of product, slightly contaminated with sulfuric acid. I like to work with pure substances, so I recrystallized it from 200 milliliters of methanol. After 1 day in the fridge, I filtered out pure dimethyl oxalate. Here is my final product with a yield of 160 grams, much higher than when using undried oxalic acid. That concludes today's video. Goodbye.